Okay, for classification, we can also use several other models. So we can use multiple models, and we can check the performance of the model. For example, last time we also use K and N. This is K nearest neighbor. So K and N looks at the K closest data point in the training set. I think we will discuss more about K and N. So for classification, it assigns the new point to the most common class among those K neighbors. Okay, so this is the concept of the K and N. And we also learned last time about the decision tree. The decision tree, or sometimes we call it tree, the decision tree classifier. So the algorithm select the feature that best split the data into subsets, aiming to the highest proportion of the training set. So we can see the example. If you use orange, it is only to get the widget, for example, the logistic regression, and then, for example, the KNN, N3, and then you can check the test and score. So the test and score is the performance. And then for the tree, you can look at the tree viewer. You can see the decision tree. And there is also a widget for confusion matrix. So the confusion matrix, this is the accuracy that we learned last week. So the accuracy. The accuracy is noted here. CA. CA means the classification accuracy. Classification accuracy. So accuracy, the higher the better. So the range is in between 0 and 1. The value closer to 1 is the best. So if you look at this one, logistic regression, it shows 0.714. KNN, it shows 0.571. Decision tree, it shows 0.571. So which model is the best? The best model is the highest accuracy. So this is the best model. So we will select logistic regression for this data because it shows the best accuracy. So in different case, maybe in other data, sometimes we need to select AUC. So the AUC is also high. For example, like this one, KNN, it shows the same accuracy with decision tree. So which model shall we choose? If they are the same, then we can look at the other metric. For example, F1. Okay, they are the same. Precision. Okay, they are the same. Recall. They are the same. MCC. So I didn't explain about the MCC. MCC, they are the same. Then, if you look at the AUC, okay, they are slightly different. Then we may choose decision tree because the AUC here is higher than KN. Okay. So I will explain more about the AUC and stuff later, but now let's just choose accuracy. Okay. So whenever you create a model, so just select the accuracy for the selection. And you know that we can select whether using the cross validation or random sampling. So we need to select how much data that we want to choose for the training set. In this case, 70% for the training, then 30% for the testing. Now, we have the decision tree. We need to understand the model interpretation. So how to interpret sound in model sensor sound audio. So let's look at the first part. The decision tree start from the top to bottom. So the top here means I know there are 9 data which shows yes among 14 data. So there are 14 instances, there are 14 rows, and 9 from 14 data belong to the class yes, play ball. So if there are 9 from 14, yes. So the remaining, which is 5 from 14, it is no. Okay. In orange, you can see here, for example, no. If it is 50%, it means it is not yes, it is no. We cannot distinguish. That's why the color becomes white. If it is more to yes, 64%, then the color is closest to red. So the color is pink. What about if it is 100%? If it is 100%, the color becomes red. Yes, here it is 62%. So the color is a little bit pink. What about if it is no 100%? Then the color becomes blue. Then we can see that if it is no, the color is blue. If it is yes, the color is red. But if the percentage, let's say 60% yes, then the color will be about pink. So we can see that one. Now, at first, you can see this. What is this one? Outlook. This is the attribute name. You still remember? We have the data. This one. This is our data. We want to play all. Okay, the decision is play all. And then we have 3 attributes: outlook, temperature, and wind. So we want to check which is the most important attribute. Jail, tujuan, attribute. Munci. So in this case, the first important attribute is outlook. The first important attribute is outlook. If the outlook is overcast, then 100% of the customer they will play 100% among. So it means there are 4 customers when the weather outlook is forecast for customer, play golf. When the outlook equals to forecast. Okay. Now, let's see if we go to the left one. So when the outlook is rainy or sunny, so 5 among 10 people say no. And we have rainy or sunny. So 5 customers play golf, and other 5 customers do not play golf. So it means 50-50. And then we know there is another attribute, temperature. If the temperature is hot, okay, we know that the customer did not want to play golf. Because this is no. What about if the temperature is cool or mild? Okay, 5 from 8 customers, they will play golf. Okay. So that's how we interpret this review. Then, how we can predict? So the table here show the information of the current weather. So the outlook is sunny. The temperature is cool. And the wind is false. So predict whether the customer will play golf or not. So I give you one equation. This is the equation for the logistic regression. I hope you remember the logistic regression. Okay. So this logistic regression is based on the formula from here. This is the logistic regression model. So we got this formula from the modeling when we model the data with the logistic regression. We got the intercept. And then this is the outlook overcast. This is the outlook rainy. This is the outlook sunny. And so on. Until we got the windy equals to true. Okay. So we remember this is the intercept. If the outlook equals to overcast, then it is 1. If the outlook equals to rainy, it is 1. If the outlook is sunny, it is 1. But we cannot choose all the attributes. So if it is overcast, then it means this is 1, this is 0, this is 0. If it is rainy, then it means it is 0, it is 1, it is 0. If it is sunny, then it is 0, it is 0, it is 1. Okay. The same with the temperature. If the temperature is cool, then it is 1, it is 0, it is 0. If the temperature is hot, then it is 0, it is 1, it is 0. If the temperature is mild, then it is 0, it is 0, it is 1. The same with windy. So if the windy is false, then it is 0, it is 1, it is 0. If the windy is true, then it is 0, it is 1. Okay, it depends on the data. Now, if we look at this data, now the outlook is sunny, and the temperature is cool, and the windy is false. So whether the person play golf or not. So you need to predict. Then there is a formula. The probability will be 1 divided by 1 plus exponent minus z. Okay. So what does it mean by minus z? So we will check this out. So exponent minus z. Okay, I give you this information. The exponent minus z, it refers to the e. You know e? E is the angular number. Angular number. The angular number is a constant. 2 point something something. And then we want to give the exponent of minus z. So let's see. With the logistic regression, so this is the model that we got last time. Then we can check the model by calculating the z. The z is first using the intercept. This is 1.588 plus the weather is sunny. Okay. So means 1 multiplied by minus 7. 1 multiplied by minus 7. What about the outlook equals forecast and outlook equals training? Nothing. Because this is 0 and it is 0. 0 multiplied with this number equals to 0. 0 multiplied by this number equals to 0. Then we just consider this value. Now the temperature equals to cool. When the temperature equals to cool, then it is 1. What about the other? It is 0. This is 0. And we calculate 1 multiplied by 5.14. And the temperature because it is 0. 0 multiplied by any number is 0. 0 multiplied by any number, it will be 0. The windy equals to false. So the windy equals to false, then it is 1. Windy equals to true, it is 0. And 1 multiplied by 1.8. And the result is this. 0 multiplied by any value will be 0. So the result of z equals to 1.438. So we got the z value. After we got the z value, we need to calculate the probability. So the probability is using this formula. 1 divided by 1 plus exponent minus 1.438. So this is the z value. Before, we know that the formula is exponent minus z. Minus z means the z value is 1.438. So we put minus. Then we put minus here. And the result will be this one. 1 divided by 1 plus 0.2374. And then you will get the value is 0.80811. Okay. Using this value, is it yes or no? Because this is the probability. This is on model. This is the model. Yes. Okay. Do you know the probability? Value. Value means if the probability is 0, it is less chance the person will do the play ball. If the probability is nearby one, then there is a high chance this person will play ball. So this value is nearby one. So usually people just say if the value is higher than 0.5, then it is this. So the class is yes. Then because it is higher than 0.5, then we say that the person is probably will play golf. So we have the probability 0.8 to say that the person will play golf. This is based on the logistic regression model. Now, what about if we use the decision tree? If you look at the decision tree, it is easy because we just put the attribute. The outlook equals to sunny. Okay, let's see. The outlook. If the outlook equals to sunny, then we go to the left. Now, let's see. The temperature. The temperature equals to cool. The temperature equals to cool. Okay, then yes. So the person will play golf with the probability 62.5%. So we got the answer based on the model that we have. Okay. Then you can also check. For example, I want to use K and N. So we can also see the result. Then we have the model. You can also use like SVM or maybe XG boost or other model. Then we can try to interpret. Now you already learned only two models, tree and logistic regression. This is the way to check the answers. Okay, so you already learned many things in this section. You learn about the EDA, data cleaning, data transformation, and then you learn about linear regression and regression tree, and also the performance measurement. For example, if you still remember the MAE, MSE, RMSE, MAPE, and R-square. And for the classification, you learn about the logistic regression, decision tree, and the performance measurement. So you learn about the confusion matrix, which is about the accuracy, and then you learn about the precision, recall, and also F1 score. Okay. So please review those things because there will be some problems. This is in the exam. Any questions? Then let me continue with the other section. So let me just show you how to use this data. So the file, you can go to the tree, and then you can check also the logistic regression. And then you can check the tree and score. You can check the tree and score. And then when you do this one, nothing. Why? Because this test and score needs the data. So you need to connect also the data to the test and score. Once you connect it, then you will see the result. Okay. So this is the result from the test and score. And you can also see the tree viewer. Okay, so the tree viewer means this is the tree. So when you look at the PowerPoint, it's different. Why? Why it is different? Do you know? Okay. So here we have 1, 2, 3. There are 3 levels. What about here? We have 1, 2, 3, 4, 5. We have 5 levels. Okay. Usually, if we have more levels, it is more complicated to interpret. So we can limit the levels. So here at right, you can see that. So you can limit the depth. For example, I want to see only 3 levels. Then the 3 levels will show something like this, and the result is the same. If you want to see all the 3, if you want to see unlimited, and you will see all these 3. So now our data is only 14. So our data is only 14 rows. That's why the decision tree is simple. But when you have the data, maybe like 5,000 or maybe I don't know, 1 million. So this tree will be so complicated. Then you need to make the limit. You need just maybe 3 levels, 4 levels. Yeah. So you can interpret, you can explain what does it mean by this tree. Okay. And the other thing that you can look at this one, you can provide the confusion matrix. So this is the confusion matrix. You learn last week how to calculate the accuracy. So this is the confusion matrix for the decision tree. And then you can also click on the logistic regression. This is the confusion matrix for the logistic regression. So you can see it is different between the training and the logistic regression. And for the decision tree, yeah, there are some parameters. Now I will skip that one. Okay. So you can just use default. Okay. I will explain more later about this parameter. Okay. Any comments, questions? So let me continue with the next section. I'm going to change a little bit about the content from the syllabus. In the syllabus, I want to explain about unsupervised learning at the first time. But I think I will, not unsupervised learning. I would like to explain about deep learning actually in this week. But I think it will be good if you do more practice for the deep learning. So I will put deep learning after meeting section. Okay. So I will just explain about machine learning more for meeting section, and I will explain the deep learning meeting section. So let's continue about the machine learning stuff. In this section, I would like to explain three kind of things. Okay. So first, I will also again explain about the data preprocessing, which is about data transformation and maybe we call it the feature selection. And we are going to look at more about classification. We call it multi-class classification. And how we can explain. Because some of the algorithms, they are so complex and it is difficult to explain. So we need to learn how to explain the model. So for this section, I'm going to use three kind of data. So you can check on the class. There are three data: salary data, small, and then person age, and then the color data. So if you still remember the flow, when you have your data, first check your EDA. So the EDA means you need to check the statistics, the minimum, the maximum, the mean, the standard deviation, whether they have the single value or not. And you need to check the data visualization. So we can check distribution. We can check the scatter. We can check some information from the chart. So in the data preprocessing, there are many steps. Okay. But I will not explain all the things. Today we are going to focus on this data transformation, which is discretized and contiguous. So those things are important before we do machine learning. Discrete. What does that mean by discretized? We call this discretization. It means we will divide the range of a continuous aggregate in the block. So do you know continuous aggregate? Continuous aggregate. We call it continuous because it is numerical. If the data is number, then we call it continuous aggregate. And usually in the numerical data, it is difficult to understand the range. For example, if it is age, we can understand. For example, okay, the age is adult. Okay, maybe the person is children or in. The person age is 68. Okay, maybe this person is senior. The person age is 45. Okay, maybe the person is adult. So we can make a kind of condition. So the condition will be different from one data to another data. For example, now I have a condition. If the age is between 0 and 3, then the person is baby. If the person is in between 4 and 13, then the person is child. If the age is between 14 until 65, then adult. If the person is in between maybe more than 65, then he is senior. So we can have this data and we can change to this category. If this person is 10, the age is 10, then okay, category is child. If the person age is 68, then the category is senior. And so on. So how can we do this one? So there are three kinds of strategies. The first, so this is the discretization method is the first we call it binarization. So binarization means both continuous and discrete attributes may need to be transformed into one or more binary attributes. Binary. So binarization is from the word binary. The word binary means 0 or 1. Okay. Or maybe true or false. So the options only two. Okay. The options only two. Whether you have 0, 1 or true or false. In the binarization, usually it requires a threshold. There is another strategy, we call it pinning. Pinning. Pinning is a way to group a number of more or less continuous values into smaller pins. So we call it pins. This kind of vacuum. Or the other kind of strategy, we just use the statistics. Okay. For example, we can make the value discretization using quantifier. Or maybe use some distribution, for example, uniform distribution, and etc. Now, let's see example. One of the example for the binarization, we can discretize the numerical values, and we can set up a threshold. Threshold. What is threshold? We call it threshold. It is the cut-off value. For example, a threshold can be a domain knowledge. 전문가, 전문가 지식, 전문가 지식 있으면 okay, 전문가 지식은 사용이요. For example, based on the expert, the threshold is 0.5. Okay, we can use this one. And if it is higher than 0.5, maybe it is good. If it is lower than 0.5, it is bad. Or we can check based on the statistics, the average. For example, this data. I have this data, and then I want to know how to split this data into 0 and 1. Then I would like to make the average. Let's say this is 1.5 to 5. Then if the data is higher than 1.5 to 5, it is 1. If it is higher than 1.5 to 5, let's consider it is 1. If it is lower than 1.5 to 5, then let's consider it is 0. Or you can use media Q2 and so on. So the threshold is something that you need to determine, you need to decide, you need to select. Now, let's say I have this data. This data is something, maybe from sensor. We do not know. Then what that we can do is, let's look at the statistics of this data. Okay, the average is 1.5. Then, okay, let's just consider to put as binary 0 and 1 is on the average. Second data is about salary. Let's say this is a salary in USD, in US dollar. And okay, I want to know which salary is high, which salary is low. Because this data is a little bit confusing. Okay, then you can check. The average of this data is 3,800. Then I can say like this. If the salary is more than 3,800, then let's consider the salary is high. If the salary is less than 3,800, then let's say that the salary is low. Okay, now let's look at the orange. How can we do with this parameterization? In orange, you can save your data. Okay? You can do the file, and then you can save as. Let's say I'm going to save it in this file. Maybe I want to save this one week 05. It is about machine learning. So you will get the file name is orange workflow.ows. So on Thursday, I will give you one assignment to work with orange. So you need to save this file and then you need to send this file for practice. Okay. Now let me just make a new file. Okay. And then I will do with the data salary, the salary data that I have. Now let me open the salary data. Salary data small. So if you look at the data table, so this is the data, the same with the PowerPoint. So we have the salary, we have this data, and then you can check the statistics. How? You can check the feature statistics. So in the feature statistics, you can see the average, the median. You can see the mean is 3,800. The median is 2,500. The mean is 1.6. The median is 2.1. Okay. So I want to make it discretized. So I can make it into a formula. So in the formula, there are two kinds of formula. So you can make numerical formula or you can make categorical formula. So I will skip the text and the data. So one numerical, for example, I will give you this. Let's say I will use this function. So I can put in the function 0 if the salary is higher than 3,800, else equals 1. So if you click this one, after the formula, you can click the data table, and then you can see there is a new column. The new column is 1, 1, 1, 0, 0, 0, 1, 1, 0. So it is based on the data salary. If it is higher than 0. If it is higher than 3,800, then it is 0. If it is not, then it is 1. So with the same formula, you can also create another, let's say, categorical attribute. So I want to put this one into this, and then the first is high, and then the other is low. So I have the value. The value is high if the salary is higher than 3,800, and the value will be low if it is lower than 3,800. Then you will check. I need to send this. Then you will see this result. It is below the average, then it is low. If it is higher than the average, then it is high. Okay. So we can use the if condition to make a new attribute. Okay. Oh, because of the time, then I will stop here. Let's continue on the street. Okay. Any comments, questions?